Okay, so what we're going to do here is a simple partial fraction expansion into a Laplace transform to find x of t for the system. So, as you can see, I've already gone ahead and separated these out into three separate variables over a different portion, a different factored portion of the denominator. It's essentially foiling, but in reverse. So in order to solve for each of these values, you have to go through and you have to substitute in the value for s into these equations while also multiplying through by all of these. So what you'll do is you'll get an equation that looks kind of like this. And now in order to solve for each of these, you're just going to substitute in the value of s. That corresponds to at least one of the terms in each section going to 0. Which, in order to find a, you'd set s equal to -2. So, let s equal -2. So now you have 1 equals a times As you can see, the other terms don't really matter once you get there, because both of these will just go to 0. So now you're left with 1 equals a times eight. So a is equal to 1/8. And if you keep through and solving these, you'll end up finding that b is equal to 1/4 and c is equal to -3/8. Now once you get here, you're going to substitute these values for these variables in to this equation all the way up here. And from there, it's a simple Laplace transform that you probably did in Diffie. We're going to take the inverse Laplace transform in order to find x of t. So we have 0.125 over s plus 2 plus 0.25 over s plus 4. Let me get rid of that. Minus 0.375 over s plus 6. Okay, and what's going to happen here is you'll need to remember that the inverse Laplace of 1 over s plus a is equal to a e to the negative at. Okay, so now we'll have x of t equal to 0.125 e to the negative 2t plus 0.25 e to the negative 4t minus 0.375 e to the negative 6t. And there's your answer. Congratulations, you now know how to do partial fraction expansion.